Welcome back, and here we go. Today I want to teach you one strategy for finding the area or the volume of a composite figure. So go ahead and make this the title of the next page in your math notebook. You've done that. Mark that page and close it up. All right, so some words here. When we talk about 2D figures, we talk about things like rectangles, triangles, parallelograms, trapezoids, circles, pentagon, hexagon, all that. All of these things kind of have their own name that shows what they are, and since they're 2D figures, their inside of their figure calculation is called their area. We've dealt a lot with that. And then 3D figures, we've looked at triangular prisms, rectangular prisms, and cylinders in particular. And 3D figures, which we're going to be back at today, their interior calculation is called a volume. The composite figure is what we need to figure out first. What is that? Well, it's something like this. This is a composite 2D figure. And composite means it is composed of more than one type of shape or figure. So this one's a half circle and a triangle put together. We call that composite. It kind of looks like, or sounds like kind of like combination, combo, composite combo. There's a combo figure of multiple things. So when we want to find the area of a composite figure, we have to decompose it. I know that's a word you hear a lot in math, especially in elementary school. Kind of means take apart. To decompose it into multiple figures. So this one, for instance, when I want to find the area of this figure, I'm going to do it separately, or today's strategy at least, is I'm going to teach you how to do the parts separately. So we'll do the half circle. And then separately, we'll find the area of the triangle. And if we find those both, we can combine their areas and we'll have the area of the composite figure. So let's start with the half circle. The formula for the area of a whole circle, area of a circle is pi times the radius squared. And in this case, I don't have the radius. I'm given the diameter is 8 meters. So we can do the radius is half of the diameter. So the radius would be 4 meters. So the area of the circle, the full circle, keep in mind, I'm not finding a half circle, but if this were a whole circle, full circle, its area would be pi times 4 squared, which is pi times 16, which is, let's get my calculator up here. Slide that down where you can see it all. So pi times 16. So the area of the full circle, now keep in mind that's not what I need, is 50 and 24 hundredths. That's the full circle. So if I want half the circle, I would divide that in half. Half of 50 is 25. Half of 24 is 12. So the half circle area is 25 and 12 hundredths square meters, since we're measuring area square meters. So that's the half circle. The triangle, the area formula for a triangle is base times height divided by 2. So in this case, most triangles, I warn you, the sides are not always the height. This one it is, since this is a right angle. This side of the triangle goes from the base straight up to the highest point of the triangle. So actually that side is a height for this triangle. I'll do some erasing here because some of my circle stuff's kind of in the way. So this one's pretty straightforward to calculate. Here's the base, 12. Here's the height, 8. And then after we find that, we're of course going to also divide it by 2. And I'll do that real quick on here. And we'll have both parts. I'm going to add them together. 12 times 8 is that. Divided by 2 is 48. So the triangle has an area of 48 square meters. And that's what we need. We just have to add those together. And we've got it. So 48 plus 25 and 12 hundredths. Hopefully no big thing. 73 and 12 hundredths square meters. So hopefully not too bad. Just find the parts, add them together. That's an area example. Composite figures can also be three-dimensional and in volume. So here's a house-shaped figure. It is also a composite figure. Remember, composite means combo. When I see this house-shaped figure, what I see is, if I were to kind of cut it here, which would be also back here, if I were to kind of mark those things, there is a triangular prism on top and a rectangular prism on bottom. And again, I'm just going to find the volume of the two parts, add them together, and I'll have it. So the area for any prism, keep in mind, is the area of its, the formula for the volume of a prism is the area of its base, which we calculate with a big B, represent with a big B. That's the area of the base. So like for the triangular prism, the base is the triangle. Even though it's not sitting on that base, it's still a triangular prism because it's got two triangles and then three rectangle sides. So the area of the base times the height. Same for a rectangular prism, but its base will be a rectangle. So sometimes we just do length times width times height for the rectangular prism. That can be a little easier. Either will get the same thing. So let's start with the triangular prism. So I need the area of the triangle first. Difficult. So first, you got to look around here. You'll notice I'm not given the base and I'm not given the height. So sometimes with composite figures, you've got to do a little calculating or a little digging just to find the dimensions that you need. So the base is the same as this base down here. You'll notice those are identical. So its base is pretty easy to find. That is 6. But what about its height? I got the height of the whole thing, from the bottom all the way to the peak of the triangle is 11. So what about just the triangle? Well, if the rectangle is 7 tall and the whole thing is 11 tall, then the height must be the other 4. The 7 for the rectangle here plus the other 4 must be the triangle to make 11. So now I've got the base and the height. So let's start with the big base. The area now of the triangle is the base times the height divided by 2. So that's base 6 times height 4. That's 24 divided by 2. Don't forget to divide by 2. So that's the base of the triangle times the height of the whole prism now. So I know it's weird to call this the height because it doesn't go up and down, but since this is a base and this is a base for that triangle, the height is this other dimension going back. So the whole thing, its kind of depth, which is the height here, is 8, which is 8, which is 8. So it's 12 times 8, and if I remember correctly, 12 times 8 is 96. I'm not great with my 8. Don't hold it against me. That's the volume of the triangular prism. Let me do some erasing here since that's kind of confusing. And let's find now the volume of the rectangular prism in the figure as well. So mark that, mark that. So I'm just going to use this length times width times height formula. It's pretty quick because what you'll see is when I do the length times the width here, that is the area of the base. So the area of the base is 8 times 6 is 48, times the height is 7. That I'm going to need a little help with real quick. 48 times 7 is 336. So there's the rectangular prism. There is the triangular prism. Add them together, and we've got the whole thing. 432 cubic. Doesn't tell me what those are, so I'll just call them cubic units. That's how you find composite area and volume. Hopefully not too bad. Let's do one or two quickly together. Pause here and write this. So first thing to know is this word here, composite figure, kind of means like a combination. Combo is how I think of it. It's a combo of a half circle and a rectangle and a triangle, actually. I'm going to have to do this one. I'm going to have to cut that into a rectangle and a triangle. So that's going to be a 3-parter, which will be some serious work. Let's see. I'm going to label that. Like this can get a lot to do if you don't keep up with your work carefully. So I'm going to kind of mark what I'm doing at a time. So I just do one at a time. I don't get too overwhelmed. I'm going to deal with the half circle. Then I'm going to deal with the rectangle. Then I'm going to deal with the triangle. Okay. Let's start with the half circle. So if it were a whole circle, which it is not, I would use the area formula for a circle, which is pi times the radius squared. Don't have the radius, do have the diameter. So if that were smaller, cut in half rather, not smaller, the radius would be 10. So the area is going to be pi times 10 squared, which is pi times 100, which is about 314 square millimeters. Okay, so there's the half circle. Oh, whoa, almost made a mistake. That's the whole circle. I don't want the whole circle. I want the half circle. So I got to divide that by 2 because it's only half a circle. Easy, easy, easy mistake to make. You'll just see how like I feel very done after I do the formula. And that can be an easy mistake to make. So I'm glad I almost made it. 157 square millimeters for the half circle. All right, I'm going to erase that. That can be a good habit too. Like if you mark up one figure, getting rid of your marks there can help. So the other things to do are this rectangle and the triangle. So I'm going to divide this figure or decompose this figure into 2 parts. So be careful here. This 32 is a deceiving number because it's not actually part of either figure. It's not part of this rectangle and it's not part of this triangle. It's actually part of both. And so I need to not be distracted by that number. It's not actually the base of either thing. So if I start with the rectangle, because it's easiest, area of a rectangle is just its base times its height, or its length times its width, however you want to think about that. Here's its length, 20, not this. So be careful with that. That 20 and this side is also 20. So that's its length, that's its width. So its area is 20 times 14. 10 times 14 is 140. So 20 times 14 would be 280 square millimeters. Now we're on to the triangle. The area of a triangle is base times height divided by 2. So again, careful, 32 is not its base, and actually its base is not given to me at all. I'm going to have to do a little bit of calculating. This base here, if this whole side is 32 and that's 20, then this must be the other 12. So its base is 12. Its height is the same as this because of that side's 14, so is that side. So its area is 12 times 14 divided by 2. 12 times 14 is that, divided by 2 is that, 84. So now I've got 3 different area measurements, and I just have to add those together and I'll have it. So 84 plus 280 plus 157 is 521 square millimeters. So as you can just see looking at the slide and probably looking at your own paper, you've written it down, these are a lot of work. They're not really that difficult. We're just doing a whole lot of area problems all at once. Tomorrow in class, I don't have time to do the volume one. Tomorrow in class, we'll also do a volume one. If you want to try it before we get there, I just don't have time to work it out before I'm out of time. They're just kind of a lot of work to do, but hopefully they're not too bad. If you just stay patient, divide it into its pieces, hopefully you can do it. So do a little check for yourself to see if you need to watch or try any of this again. When I show you a figure like this, could you decompose it into things like rectangles, triangles, circles, prisms, and cylinders? And then could you use formula to find the area and volume of those part figures to find the whole thing? So hopefully you feel good about it. Hopefully it wasn't too overwhelming, and we'll do one extra example in class tomorrow, and I'll see you then.